So now normally when you're using LEDs, you have a resistor to protect them from the voltage that you are applying. In this video, we're going to use very low voltages where we can safely put the LED directly to a power supply, but at very low resistances. So for the most part, make sure you have a resistor to protect LEDs, but there are cases where you may see, usually like just little projects where people want to light something up for a party or something. They might have LEDs that really aren't properly protected, but it's still okay because they're not intended for long-term use. So to begin with, we have a 1 kilo ohm resistor, 1000 ohm resistor, and a red LED. Pretty common situation. So there's only 1 volt across it now. Nothing is lighting up. I'm going to go here and put 11 volts right there. And we have somewhere around 8 milliamps of current going through the resistor and the LED right there. So you figure 11 volts from the power supply, the LEDs blocking about 2 volts in that range. The rest of the voltage goes across a 1 kilo ohm resistor. We expect around 9 milliamps of current. And this meter is not perfectly accurate, but tends to be just a slight bit lower than what is actually going through there. It's usually pretty close, not too bad. So, in any case, we have that situation there. Now we're going to lower the voltage, and we're done raising the voltage like that for this video. So, we're going to zoom in, and I'm going to pluck the LED from here. You can see I have a yellow jumper going directly to the positive rail, a gray jumper going directly to the negative rail, the blue rail there. And I don't know what that current flickering is. I think it's just the capacitors within it that may be bouncing around a little bit. But in any case, we have the long lead. The anode, of course, has to go to positive. Short lead, the cathode, has to go to negative for it to light up. And it will also light up at a lower voltage. If we put it in backwards, it will block a lot more voltage. And if current starts flowing through it, well, it's reverse bias, it will probably damage it. It probably won't work like a new LED anymore. So I couldn't find my little bag with a bunch of different color LEDs like this, so I just started a new one here. So these are all fresh LEDs right out of the kit. So we'll look at that kit coming up a little bit. First, we're going to go over here. So this LED is directly to the power supply right now. That is the important thing. And we expect red LEDs to really block about 1.6 volts. Let's turn the light off and see if we even have a glow. We do have a slight glow right there. So I'm going to set it down a tenth. You can see it goes off, up a tenth of a volt, and let's go up another tenth of a volt. You can see that the LED turned on right there. So you can see 1.7 volts. So really not terribly bright. This lamp is at its lowest setting. I can turn it brighter. Like that, it will wash out the light a little bit more, but we'll turn it down. So now we will go to hundredths of a volt, and you can see as I press the button it goes up, and we're going to start seeing current be displayed there. So we're probably close to about 5 milliamps of current, even though this says right now 4. We're probably closer to 6, but this isn't spot on, but it's still pretty close. It's usually just a tad bit below, and we can prove that. So we have here 0.06, and of course we can go up a little bit more. Let's try seeing if we can get to about 0.10, but there you can see with just a hundredth of a volt difference, it's making a fair amount of difference on the current. So we have to be really careful. It doesn't take much voltage for current to just rapidly escalate. So I'm going to set the meter to measure milliamps right there. I can leave the red probe right there, and we're going to pluck that resistor and put the LED up here. And so now we got to complete the circuit. So we're putting the long lead, the anode, to the positive rail, short lead, the cathode, down 1 row, and we're completing it through the circuit. So yeah, it looks like it's only about 1 milliamp difference, but it's a little bit higher, about 8.5 or so, and we got 7 on there. So we don't know if it notices a little more than 7 milliamps of current, but you could definitely see it was just a tad bit lower than this. So it's doing pretty good. So that is the red LED, and I'm going to lower, we're going to be done with this meter. That was just to prove that our current reading on here is you know, accurate enough. So this isn't a crucial circuit where we need exact amount of current, but it is nice to have a good estimate. So let's go back to 1.85, and so this is blocking about 1.85 volts. Well, it is blocking 1.85 volts. That's the voltage we have across the LED, and due to that, I meant to hit that. So we got 1.85 volts across the LED, plus there's some resistance in the wires and stuff. It may be dropping a tiny bit, making it to the LED. Let's do another multimeter measurement here of the voltage across the LED. So that is another thing to look at, because we're dealing with such low power that we may be losing a little voltage. So no, it looks like we're pretty good at 1.85 for the most part volts across the LED. So the very tiny resistance in the wires is not taking off hardly any voltage, it looks like on here. We're pretty good. So what I'm going to do is we'll go back to looking at current, and wrong button again, there we go. Looking at current, we'll pluck the red and the yellow. We expect to have about the same electrical properties. Right there, yellow, and I think we got less current, don't we? So it looks like the yellow one might block current a little bit better. So yep, blocks current a little bit better right there, and we can go set, go over, and work our way up and see. So yellow is pretty dark, but there you can see it doesn't display very much, I should say. It's not really dark, but it's kind of hard to see. So we are going to yank this. The next three LEDs, so I know just from experience that they block more voltage, but also here's the kit that I got them out of. So you can see them all right there, and these are brand new, never used. So when I need a never used one, I pull it out of here, and then I stick them in little baggies afterwards to know I've used them before. But there you can see 1.8 to 2.2 volts. Same with the yellow one. You see blue, green, and white. You see 2.8 to 3.2 volts. So they block more voltage before they start conducting. So let's grab the blue one first, and we'll probably really recognize when this starts conducting. So let's go to 1.9 and then 2. So we should be good up to about 2.8. I see a little glow right there. The blue one's glowing a little bit. Let's go up, and there's no current going, so I'm going to go up another 1/10 of a volt. You still see no current, and there we go. Now we're starting to see current. So let's slowly work our way up, and we saw we could get up to, I think, about 3.2 volts. That's probably a little high, I'm betting, but there you go. We'll get it up to maybe 9. So it takes about 3.07 volts to get to about 10 milliamps of current. I bet this is slightly more than 10, maybe 11. But in any case, just in case the other two are a little more sensitive, we're going to work our way down. But there you can see the LEDs have a little bit of defense against current. Not a lot. You do generally always need a resistor, but as you can see here, sometimes you can get away with it if the power supply has a low voltage right there. So we got 0.2 there, and so it's barely conducting, but these again are a lot brighter at low current than the red and the yellow one. The yellow one, as we saw, was really hard to see, and there's the white one right there. So in any case, as I said, you may see from time to time LEDs directly to a power supply. So I haven't come across one yet, but there's probably LEDs somewhere out there that are rated for a certain voltage because they have a resistor within the component, and then that would make sense that you need a certain voltage, because there's a certain resistance. If you put that certain voltage across it, the LED and the resistor will give you an expected amount of current. So whatever the voltage is, that's probably the voltage for 20 milliamps or whatever. You'd have to read the description of the LEDs. And by the way, I haven't come across one myself in person or online, but I have heard that they exist. LEDs with resistors in them. I do have flashing LEDs that I think have some internal resistance. They seem to do better at a high voltage than these ones, but I don't know for sure. So in any case, that's all stuff to test. As you can see, it is really easy. And if you have a power supply like this where it gives you the voltage and the current, as you just saw in this video, there's a couple ways you can verify that what is displayed on there is what is actually being provided to the circuit. Voltage though gets divided up amongst all the components based on the resistance and the voltage drop. So this has a high voltage drop, and the wiring and stuff has really low resistance, so practically all the voltage made it to the LED. When we had the resistor in series with the LED, the LED blocked a certain voltage, and whatever voltage we went above that got put directly across the resistor because it had fairly high resistance. So we took a current measurement though. Current goes through everything equally if it's one path, as we saw there. So when we took the current measurement, this meter was set to a more accurate setting. When I had it at the amp setting in the last video, it wasn't. It was about the same accuracy as this one. But then when I dropped it to milliamps, and it gave us more decimal points to look at, this one had a slightly higher number than that one, or slightly different anyways, but it appeared to be more accurate. So in any case, hopefully that all made sense. This is fun experiments to get to learn basic electronics better. So they're not doing anything terribly interesting, but we're learning about the electrical properties of LEDs, which is very important in circuits where you are doing something interesting. It's important that you already know these principles. So I rambled on long enough. Thanks for watching. I'll see you